Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong, RedHat Marketplace, and MinIO. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting presentation ahead of us, but before we begin, I have just a few housekeeping notes. First off, today's session is being recorded, so if you miss any of the session or you'd like to share it with a friend, the on-demand will be made available shortly after the webinar concludes. I'd like to direct your attention to the right side of your screen where you'll see a couple of options. First one is the Q&A tab, and this is where we want you to send in any questions that you have for our presenters today. Right next to that, you'll find our chat tab, and that's where we want you to talk with each other, talk with us, let us know where you're tuning in. Next, you're about to see something pop up on your screen, and that I'm just triggered a poll. So this is a short poll that our panel wants you to answer today. And the results of this poll are going to be discussed a little bit later in today's webinar. I'll also let you know that the slides are available for download if you just navigate over to the Handouts tab, which is also on the right side of your screen. And my final note is that at the conclusion of today's webinar, we will have a drawing for 4 $25 Amazon gift cards. So on to our topic at hand. It is multi-cloud object storage on Kubernetes with MinIO and RedHat OpenShift. And I'm joined today by Ur Tigli, CTO at MinIO, Daniel Valdivia, engineer at MinIO, and Dan Kirsch, managing director and co-founder of TechStrong Research. And at this point in time, it is my pleasure to turn the floor over to Ur to get us started. Thank you so much for being here with us today, guys.
Thank you, Cody. Thanks for joining us for the webinar. Today, we are going to be talking about multi-cloud object storage running on Kubernetes with MinIO and RedHat OpenShift. Before we start talking about the details, I just wanted to talk about the agenda of today. We are going to cover I'll let Dan to talk about the changes in the industry from an application perspective and the importance of Kubernetes right after this slide. And then I will take over and talk a little bit about how you can connect MinIO object storage, S3 compatible object storage into the new world of Kubernetes ecosystem and architectures. And then I'll let Daniel take over the presentation. He will explain what MinIO have done in the last couple of years, specifically about Kubernetes deployments with MinIO operator and our console. And he will also do a demo during that. After explaining a few theoretical aspects, he will do a full demo of our operator as well as the console. And at the end, I will take over the presentation and summarize what we have seen today. With that said, I'll quickly turn it over to Dan, who's going to talk about the changing nature of applications in the industry today, or the last couple of years, to be honest, and then Kubernetes and how Kubernetes played a really critical role in the multi-cloud environments of most of the enterprises that are running their infrastructure from a DevOps and an IT perspective.
Thanks, Or. So let's talk a little bit about where we're coming from and where we're going. So we're used to these monolithic applications, whether they're corporate apps or customer-facing applications, these big applications that, frankly, they don't get updated often. You're lucky if you get an update every 6 months, and maybe you'll do a major overhaul every 1 or 2 years. That just doesn't meet today's needs, doesn't meet customer needs, doesn't meet the needs of the quickly changing marketplace. So we've moved to an era where applications are made up of various services. Some of those services you control, some of them are controlled by third parties. And Kubernetes plays a huge role in this. It's really the standard. The industry has really standardized on Kubernetes, and it helps organizations run across multiple clouds. Let's just take a quick look at the poll, and it looks like, does your organization run Kubernetes orchestrated workloads on multiple clouds? We're pretty split here. Slight majority says yes. So I'm going to hand it back to Or to talk about the importance of Kubernetes across multiple clouds.
Thanks, Dan. So as Dan mentioned, applications change. There's a new world out there. People are running things in a cloud native, microservices fashion, and their architecture to host these applications for whatever use case, whatever application they need to run has changed dramatically. Kubernetes essentially is a glue that connects all of these new trends and concepts in the modern multi-cloud architecture, whether you're running it on-prem, running it at the edge, or running it on one of the public clouds. The concepts are pretty much the same. Kubernetes is that abstraction, is that glue that connects all of these trends and concepts together. Why Kubernetes became the popular choice in cloud native architectures and then became the standard for the cloud architectures of today? Because of its background and its philosophy that's where it started and where its philosophy that the developers have stuck to. It's the open source way of thinking, leverage the learnings from the hyperscalers. As you would guess, it was designed to run a hyperscaler environment, and API and automation made that easier for everybody to adopt and made it scale tremendously. It's essentially the technology that provides the abstraction across cloud, similar to virtualization, which provide the abstraction for multiple physical servers. Now, Kubernetes is the abstraction technology that can connect all the computing infrastructures, whether it's public or private or edge type of clouds. It simply was the better choice to manage many resources, and it was software only, and that made it the clear winner and choice for DevOps, clear choice for large-scale IT operations, because you could really have operational cost savings just by using this technology, and you don't have to do things in a very monolithic and old school way. And that helped treating infrastructure as a code, and Kubernetes was the main player in achieving this success, in my opinion, and according to many in the industry, as Dan also mentioned. Object storage also played a common role together with Kubernetes, because object storage started, especially S3 as a protocol, thanks to Amazon Web Services. AWS S3 started as the cloud native choice for persistent storage. Legacy environments like NAS and SAN, and especially NAS, used file systems and POSIX type of protocols, which were considered to be legacy, chatty, and not really fit for the cloud native environments, the multi-cloud environments of today, because they were just meant for the data center. The chattiness, the latency, there are a lot of technical reasons why, and many choices in doing a lot of things that are not required by the modern applications. Modern applications just required simple puts and gets and reads and writes, and that was not the way of POSIX. POSIX was designed for a different era, for different things, and modern applications required RESTful APIs that are simple to operate, and object storage became popular in Kubernetes world, in the modern cloud world, because of that reason. Scale was another factor. POSIX file systems and SAN and NAS were designed for within the data centers, whereas S3 as well as object storage was designed for large scale across multiple data centers or huge amounts of capacities of storage. Another factor is you wanted commodity hardware and the software taking care of the data protection. All the advanced algorithms like erasure coding, bit drop detection, locking the objects, and all the enterprise features people needed could be achieved simply on top of the object storage, on top of the S3 APIs. And this made life so much easier for the cloud-based applications, microservices, to be able to use object storage rather than the legacy block or file-based approach. With that said, MinIO started just to fill that gap. MinIO started just to address that need in the industry, because NAS and SAN was not cutting it, just because of all those reasons. The across data center usage, the cloud native applications being across multi-clouds and across the world, if not even just different data centers, but different geographies. And you needed a HTTP-based protocol to be able to reach the storage, persistent storage anywhere, but at the same time, get all the protections. So MinIO was started on that premise, and MinIO focused on doing object storage and object storage only, and became to fame by its compatibility to Amazon S3. Amazon S3 protocol, as well as the services as people know it, you could get both of them together with MinIO and deploy it on-prem, deploy it on your laptop, on an edge, on multi-cloud. It can go to exabyte scale, and simplicity of running MinIO made it so popular in the industry. And today we are talking about MinIO and Kubernetes and OpenShift integration just because of that popularity. Simply put, MinIO is a high-performance object storage that is Kubernetes native, and it is built for large scale, but simplicity in mind by integrating into Kubernetes distributions, by just simply deploying on bare metals or VMs. It doesn't really matter. MinIO is that abstraction layer that provides you persistent storage across all clouds, edge, public, private, or any other platform. And it's been done in a way, it's been built in a way with the performance in mind. And we are the fastest performance object storage in the industry today because of some of the technical details that we paid attention to, and which we can go into it in some of the later slides. I just want to go back to Kubernetes native object storage, and that is becoming synonymous with MinIO nowadays, and why that's the case. And we are seeing that when we started initially in 2014, 2015 timeframe with MinIO, it wasn't the case. But after 2-3 years, Kubernetes and containers became the standard building block for modern IT infrastructures, whether it's AI, ML workloads, or a DevOps type of environment, or a classical IT environment for collecting certain records. It became the standard. We were built natively for RESTful APIs that made it so much easier for integrating into different applications. We have open source roots and DNA that made it very popular and easy deployment, made it so much easier to deploy and integrate into applications that people were developing or started developing a couple of years back. And at the end, when containerization became a huge trend, a lot of people started running MinIO, and on our website in different metrics, you can see the amount of downloads from a container perspective. In this slide, you can see 62% of all MinIO instances are containerized, and out of that, you can see 43% of those are managed by Kubernetes. We're getting to that 50% of all MinIO is getting managed by Kubernetes. And that's why we are here today talking to you about the advantages of multi-cloud and use of persistent storage in the form of MinIO operator in different clouds using RedHat OpenShift. When you take this one step further into the multi-cloud world, MinIO can be, as I mentioned a few times, can run in any environment, bare metal, virtual, or container. However, when you go into public cloud and you really don't want to have different persistent storage solutions, Azure, Google may have their own storage solutions from a S3 equivalent perspective, but the APIs are slightly different. Azure doesn't have any of the S3 there. They have their own blob storage. There are differences. And if you're truly trying to run across multiple clouds and your application just wants a single gateway, single point of entry, single API stack, then you come to MinIO. MinIO is the abstraction for that because, as I said, this whole build up with multi-cloud, the Kubernetes and containers and simplicity that MinIO provides from an integration perspective show itself as huge benefit when it comes to a multi-cloud infrastructure and architecture. It doesn't matter you're running on top of EKS, AKS, GKE, MinIO can be the persistent storage standard and abstraction for you. And the data can go from one cloud to another, but your applications will still be talking to MinIO. It doesn't matter you're running it on a micro-KS environment at the edge or an EKS environment on the center or a private cloud environment. All of them will be running The same front end will be shown to the applications with S3 API stack. And then in the backend, we did all the work and integration with MinIO operator, MinIO console, and the full MinIO stack. And Daniel will show you how it looks like, how easy it is to configure, regardless of the flavor of the Kubernetes that you're running at, whether you're running RedHat OpenShift on-prem, and then you're trying to go into AKS, or vice versa. And on top of that, I'm going to talk a bit about all of the features that we build, which comes really handy and useful when it comes to when you go into multi-cloud. Multi-cloud could only be possible or nearly seamless when you have certain critical features. And these features are some of the very critical ones for persistent storage in anywhere, even within a data center or across a couple of data centers, but they become critically important when you are using multi-cloud architectures and you're trying to have presence in different places. These are tiering, replication, and multi-site support. Let's talk about tiering. Tiering is simply a very important feature that allows you to, based on certain time frames, the hot and warm type of an approach in your capacity of the data or the data that you're collecting. It allows you to basically have the hot data in a front end single namespace, and then with MinIO, with MinIO ILM and tiering, you can push the data that is older than 1 week, 10 days, or a month, whatever the policies dictates, to a different environment. It can be another MinIO cluster with lower cost hardware. It can be Amazon S3 or one of the other public cloud providers for you. And this is becoming a necessity or a need for many because they want to run 2 different environments, and resiliency of that is critical. So they want to run MinIO on-prem and have their main data sitting there, applications seeing the full namespace with the archived and tiered information, but they also want to keep that data somewhere else, not in their data center, for resiliency, for HA, high availability, and disaster recovery purposes. Because of that, tiering is critical, whether it's for TCO from an operational cost perspective or for resiliency and disaster recovery perspective. Tiering is really important. And we do the tiering in a bucket level, object and bucket level, and that allows people a lot of flexibility. And also, this is basically bridging you can have an on-prem OpenShift environment that is running MinIO, and that's your full namespace, and your application use that, and then you can go into a different environment, like a multi-cloud environment for saving it for legacy and archival. And it's purely for economy and efficiency in some cases. In these examples, you can see some of from SSD to HDD, or vice versa, depending. Most of the time, people use SSD in the front end and use a lower cost HDD solution from private to public, or within the public clouds, you can have multiple solution using this functionality of tiering. The next critical functionality is replication, and we have done replication at a very granular level. We support MinIO support both synchronous, asynchronous, active-passive, active-active, all combinations. And in the past, file and block replication were done at a volume level. A 1 terabyte volume type of replication was a challenge. But with object storage and how MinIO implemented its replication, we are at the granularity of the object, and we immediately replicate it at the object level so that you can get, it's a bucket level replication, but you can upload, as long as you upload these objects, we don't really wait, and we can immediately send it over across to the other side for HA and DR perspective, and your application gets across multiple to another data center, whether it's close or different geographies for longer distance. And the granularity aspect, that you're not doing it as SAN and NAS used to do as huge volumes, is the critical point, that object storage replication and the way MinIO implements is much more efficient than the old ways. And that's quite important, whether you're replicating on top of public cloud, EKS, like Kubernetes, or you have one instance of MinIO cluster and Red Hat OpenShift on-prem, and you're replicating across to a public cloud offering. That becomes quite critical. And one more aspect of that replication is we developed also something called multi-site replication. So the replication aspects goes from not 2 into more than 2, so 3 or 4 different sites can be combined under the same umbrella for replication purposes, from an async and sync and being active. But on top of that, we also replicate or make sure that the configuration of each site, from an integration perspective, gets replicated to other sites, to essentially creating a big pool of MinIO deployments across different environments. In summary, before I turn it to Daniel to go into the details of MinIO operator and console and show you guys a demo of the details, the reason why we wanted to talk about MinIO and OpenShift today in this webinar is things have changed dramatically from a Kubernetes and the architectures and modern architectures in the industry. MinIO took the leading role in providing persistent storage in that new Kubernetes world with OpenShift. And with the integration work we have done, we made it so seamless that it is just like installing another application on top of the Kubernetes ecosystem. And that's exactly what we're going to show. And the most important features that MinIO has, the performance, is that we are the fastest performing AWS S3 deployment on-prem with the right hardware. We have done the benchmarks and published about that, and that's very clear. We can extract the maximum throughput from NVMe drives with a Gen 4 PCIe bus with 100 gigabit network, and that's been proven. We have huge application catalog and marketplace from the perspective of anybody who has written into an endpoint of S3 can integrate into MinIO, and that provides a lot of partnership and ease of integration for MinIO software from a persistent storage provider perspective. We started early deployments in financial services industry, so early on we have built a strong data at rest encryption, data in-flight encryption, object locking features, and all of the things that a financial services industry would ask from a persistent storage provider. We have built that early on, and we are quite mature in that perspective. The fact that we are a simple software-only solution makes it so much easier for anybody to start deploying it, testing it, putting it in a sandbox, and going into production. When we are in production, it's so much easier to support and operationally take care of it, and that makes it so much easier for anybody who's using it to adapt and grow. And from a cost perspective, operational simplicity and ease of use turns into basically translate into a lot of savings for many. And we have a customer that I personally work with. They were a Hadoop environment. We have many use cases. We have people who have been to AWS S3 and bringing their data back. We have Hadoop infrastructure that they don't want. Hadoop is on the downside, and they want to move from Hadoop to a modern architecture for their data lake, and they use MinIO, and they halve the size of their capacity needs by just choosing MinIO and having great performance. So with that said, I'll let Daniel to go into the specific of the part of the piece that within the MinIO stack that provides all of this with OpenShift and any other Kubernetes deployment and public cloud. That's our MinIO operator, which allows you to install MinIO simply in a Kubernetes environment, and MinIO console, which is our UI essentially on top of the MinIO storage stack. With that, Daniel, I'll let you go into some of the details for operator.
Thank you. All right, so what I'm about to give you is a demo of the MinIO operator, but let me walk you through the basic architecture of it. So as you know, operators are meant to automate infrastructure running on top of Kubernetes, and we went to great lengths to build a robust layer that can sit on top of OpenShift, and OpenShift can act as an abstraction layer to our abstraction that providing access to the hardware itself. Now, the idea here is that you can build a different number of clusters on top of OpenShift that service different business units or customers with object storage, right? So, and but we didn't stop there, right? We also built a nice user interface on top of it to simplify management and orchestration of this operator, so that people could actually get started or going without actually having to open the CLI and deploy. Now, not that it's not supported, CLI is definitely supported, but we just wanted to bring that public cloud experience that you get when you go into a public cloud console and experience it on top of OpenShift. So the main architecture of the demo, pretty much, or the main idea for operator is that on top of your OpenShift deployment, you're actually deploying different tenants. Tenant is the analogy that we use to describe a different MinIO deployment, right? In this case, a tenant could be different business unit or a different team. They can have different configurations, different capacities, different number of servers, right? And they are all orchestrated by the same operator. And then OpenShift is just abstracting the access to the underlying infrastructure, be it local NVMEs or local hard disk drives. We actually built a CSI controller to actually simplify management of locally attached volumes, but you can also use any CSI that provides persistent volumes. Or if you're running on a public cloud infrastructure, they of course will give you a CSI controller that provisions the storage for you. So this makes it very consistent. So it doesn't matter if you're running MinIO operator on top of OpenShift or any other cloud provider, you'll get a consistent experience, which is very important, because if your organization is moving from on-premise and adopting, let's say, a new cloud provider, as long as there's Kubernetes over there, you can trust that the same tooling that you're running on top of OpenShift will actually work there as well. So, and after that, what MinIO brings to the table is connectivity to all the other ecosystem that OpenShift has to offer as well, right? So we do support encryption. We have integration. We have support for Vault and other KMSs. We can actually drop your audit logs into the Elasticsearch stack or a Postgres database. Monitoring, we bring some basic dashboards, but you can also bring your own Grafana if you like monitoring through a centralized location, right? We can integrate with external identity providers such as Keycloak. You can manage certificates, Let's Encrypt, or any sort of fingers controller. But you can see that all of these peripheral integrations will change from cloud to cloud, and we support all of them. So with that said, let's jump into the demo. I think it's easier to conceptualize what I'm talking about when you are seeing the demo. So now what I'm going to do is switch to my demo screen. And I'm going to give you the demo of the operator through the user interface. So once you deploy a MinIO operator, you pretty much can operate everything through CRDs and YAMLs if you prefer. But as I said before, the user interface is meant to give you an experience that you will get usually on the public cloud. And I like to start my demo with the login screen. This is just to showcase the support for external identity providers. In this case, I put an OpenIDC, so I can actually use single sign-on type of solutions. And that is restricting the access to my operator console. After I logged in, I'm greeted by a set of tenants, right? And in this case, I have two tenants, a production storage that I purposely built with NVMe, that I'm using this like my hot tier. And I have a warm tier that I built with hard disk drives. It's also like larger, right? I'm planning on tiering data here as the data is aging. But let's actually create a tenant. I think that's the best way to understand what are all the things you can configure when you're creating a tenant. So if I go now into create tenant, I get greeted by this setup wizard, where I can actually configure how big do I want my object storage to be. Let's say I'm building some video storage for NA West kind of tenant. And I'll put this into a Kubernetes namespace. We ask about the namespace so we can respect, if there's resource quotas imposed on a namespace, we can also respect those. And then after I select the storage class, I get asked, okay, which storage class do you want to use for this tenant? In this case, as you can see, I have a storage class that's abstracting NVMe drives, another storage class abstracting SSDs and standard drives. So the storage class is another way where you could control placement. If your infrastructure is only certain nodes have NVMe drives, the Kubernetes scheduler will be smart enough only to place pods there. But you can also control affinity via some other mechanisms. In this case, this is a video storage, so we know video is very dense. So perhaps I'll go with standard. I don't need the snappiness of NVMe. If that was the case, I could also pick. But that's the whole idea of that you can provision multiple tenants based on the use case that you're servicing. You can actually choose the type of storage technology that you need for that use case. Now, next, I get asked, how big do I want this tenant to be? Let's say I'm building like a large YouTube competitor. So I'm going to be placing, I don't know, 32 servers here and having one of those really nice machines that have 106 drives. I don't have that many here, so I'm getting an error. But you get the idea of the gist of it. So of course, if let's say I'm building like a 100 petabyte cluster with this configuration. Actually, to do that, I will need like 96 machines. But the idea is that now, as I'm sizing my deployment, right? So I can get a preview on the right side of what's going to happen, right? So for 96 servers and 106 drives, I'm expecting to have every hard disk drive to be a 10 terabyte drive, right? So the total number of volumes is going to be like 10,000. I can also select the amount of memory that I'll be requesting per pod. I didn't select anything here, so let's go with 64. Actually, 60, that's cores, right? 48 cores and 64 gigabytes of RAM or more. So I can also get a preview of the erasure coding guarantees that this cluster will have. So erasure coding is how MinIO protects the data from individual failure, both from drive and whole nodes. And if you see, if I go with, like, even if it's not clear what this value means, let's go with the highest value, EC8. What EC value means is that half the data will be used for parity, right? So half the capacity will be used for parity. So if you take attention to the erasure code configuration side on the right here, you can see that for EC8, my 100 petabytes of time capacity will just yield 50 petabytes of usable capacity, right? So that's what we mean with the highest value of erasure coding. Now, however, this will actually allow me to tolerate half of my servers failing. Like if I'm provisioning 96 servers in this case, I can tolerate losing 48 servers. If I was building like a smaller cluster, a smaller setup, right? If I'm saying, okay, what if I do 32 servers for this object storage or only 16, right? What's going to happen? That means that I can tolerate 8 servers failing, right? And I will still have read access to my files. We cannot take writes because we cannot guarantee that the file will survive another server going down. But this gives you a good idea, right, of the type of SLA that you can provide to your customer or to your business unit. And at the same time, you can play with it, right? If you go to EC4, now we can see that, okay, the amount of usable capacity went up to 75 petabytes, but now the number of server failures I can tolerate went down, right? Now, out of my 16 server setup, I can only tolerate losing 4, right? So if you're provisioning clusters, let's say some production use cases have some transactional data that you're throwing on NVMe, perhaps you want high EC values to protect the data against individual server failures. But for video or backups, let's say if you're building very large and horizontal clusters, you can tolerate losing more servers. If it's very wide, then you can use a smaller erasure coding value and tolerate more servers failing on you, right? So on this screen, if I were to just click create, now this will just get me my tenant, right? With all the default configurations that we yield. But the configurations that we actually expose, we can explore them very quickly. First one is, of course, whether you want to expose these services right away. So if you have some ingress controller or networking enabled access, so we can expose the services via load balancer. I'm using a cloud instance, of course. I want to get a public IP address as soon as the tenant comes online. I can configure the Docker versions of the containers that I want to be deploying. This is pretty useful if I'm deploying only hardened images, or recently with the Docker changes, you may want to use a private Docker registry. You can also configure it here as you're deploying. I mentioned you can control pod placement, right? So by default, we have an affinity clause so that not two MinIO servers scheduled together on the same physical node. But you can also mix this with another node selector. Let's say you're only going for certain OS type, right? And some architecture, AMD 64 servers. So you can control that as well as you're creating the tenant. As I showed you before, we support external identity providers. MinIO comes with a built-in. So here I can decide the users that will be seeded into the tenant. But I can also connect to an external identity provider such as Keycloak. And here I only need to provide these fields. Or if your company uses Active Directory LDAP, you can also configure it. And here you start getting the idea that we only highlight the fields that we want you to fill. We're trying to guide you through getting things done because not all of these things are necessary, right? Next is security. We support terminating TLS. And we also encrypt all the connections between MinIO pods. And by default, we actually do all of this inside Kubernetes using certificate signing request. So you don't have to do anything to get TLS enabled on your deployment. But of course, if you want to terminate TLS at MinIO site as well, we support that. You can bring your own certificates, right? And just select them from here. Now, lastly, once you have established a secure communication, you can enable encryption. So if you want to have encryption at rest, as we mentioned before, we support the most popular KMS out there. So we support HashiCorp Vault, AWS KMS, Gemalto, Google Cloud, and Azure. But we can bring online any KMIPS compliant quite easily. And that will be the case if you have some other KMIPS compliant KMS and you want to connect it, you may have to go through CLI at the moment, but hit us up, we may add support for it. So, and the same idea applies here. If you're configuring HashiCorp Vault, you go to your InfoSec team, they'll give you an endpoint, some AppRole, and some secret, right? And that's it. You have encryption at rest now. Perhaps they ask you some additional configurations. As you can see, most of these KMSs will have a lot of knobs for you to configure, and we try to let you configure those through the UI in a very simple fashion. So for this demo, I'm not going to turn on encryption, and pretty much just reviewing what I'm going to do. I'm going to do something that fits on this demo environment. So I'll go with 100 gigabyte cluster, and that's it. I'll just hit create, right? I'll be reminded of the auto-generated credentials that I have to access these credentials. This instance, I'll download those, and that's it. Now it's going to take a couple of minutes for this tenant to come online, and I'll be online. I mean, I could have done this in less than 30 seconds. So while this tenant comes online, let me show you how a live tenant looks. So if I want to see like my production tenant, how is it going? I can see it's already going half its capacity in usage. I can see the version of MinIO that is deployed. I can actually start an upgrade from here. I can see the endpoints I can use right away to start consuming this object storage. I have an endpoint for the S3 and an endpoint for the management console. I can see the features that are enabled. I can pretty much update the security if I want to add new certificates. Let's say I'm doing some replication configuration and I need to have it trust some remote service by domain. I can bring in certificates over here as well. I can expand this tenant. So if you see initially I put in this specific tenant 1 terabyte. If I want to expand the capacity, I can come here and just say, let me throw some additional nodes into this, right? I'll try another 4 nodes or another 8 because this tenant is growing. And you can do it here without actually causing downtime. The way we will do it is just by instantiating the new pods, having them start, and then having them join the existing cluster, right? I can see how the pods are going, and you get the gist of it. Many of the things that you will pretty much investigate via kubectl commands, we're trying to make them visual so you can get the big picture very quickly. So at this point, if you see, everything has been done around managing infrastructure. And you as the owner of the infrastructure pretty much can service different business units or customers and tell them, okay, here's your object storage. But now, who manages that object storage? And managing an object storage implies, making buckets, adding users, setting policies. So like right now, what I'm going to do is go to the management console that I have for this one tenant. And in this one tenant, I didn't put an external identity provider. I'm actually doing everything manually for this guy. Well, I have MinIO manage the accounts. So I'm going to log in, and here I'm going to be greeted by a set of metrics, right? These showcases are Prometheus integration. So by default, the operator will deploy as a Prometheus per tenant, and it will collect the metrics for you, right? And then all of these widgets are the ones that are also available as Grafana dashboards. But here you can see we're pulling the metrics straight for you, and you can see what's going on with the environment, right? So the number of buckets, objects, the size. I can see if there's any traffic. This environment might not get traffic right now, but after the demo, this charge will actually prop. And same for the resources that I have in my cluster. So I can see right now that everything is healthy and nothing out of the ordinary, right? But then the idea of this management console is that all the activity that it's related to the object storage can be done from here. So this is where you can actually delegate it to someone else. You can do it yourself as the owner of the infrastructure, or you can just delegate it to the data scientist who requested object storage for some data sets, right? So, and they don't need to know anything about how the object storage works, because the idea of this UI is that they can explore. Let's say they need to create a bucket. They come to the bucket screen, they hit create a bucket, and now they can say, okay, data sets bucket, right? So now, as they're configuring the bucket, they can be like, oh, maybe versioning might be good, right? In that case, someone replaces an older data set with a newer one. I want to be able to roll back that change. I can turn object locking. This is great for preventing deletion of objects, and it's a great protection against ransomware style of attacks, right? So if you want to make sure that files on a bucket can be deleted, you can turn on that protection. But let's say you don't need that protection for that long. Maybe you just want to retain data for like 6 months. Then you can do a retention policy and say, well, keep the data up to a year, right? For this specific bucket, I need that, and I'm doing that for compliance. Or you can also, let's say you're doing multi-user system, right? You're just building a very large object storage and sharing it with your organization through buckets. You can impose quotas on them and say, well, I'll give you 1 terabyte, right? So go put as much data as you want. If you run out of capacity, come back to me, I'll give you more. Or if, let's say if you were doing backups, if you were putting backups into this bucket, you may want a FIFO quota because you want the backups to never stop. If the bucket becomes full, you want backups to still be accepted, but the older backups to be thrown out of the bucket, right? And it's a nice way where you can also control how much different applications are consuming from your object storage. And the idea here is, of course, you see, I was able to discover all these features and all of the things that are related to object storage, such as browsing files, right? I can go here and an object browser is kind of like an expected functionality, right? Being able to see, okay, what are my buckets? What files do I have inside these buckets? Here I have a cat picture. It has no tags, but it has many versions of these files have already been uploaded. I can go and revert to one of the older versions. I can also preview the file if it's a file that can be previewed in the browser, right? And so forth. So other things you can configure from this setup is, for example, if you want to subscribe to events, right? So this is another interesting thing. If you want to be notified when things change, for example, we support a variety of notification targets. If you want to be notified on a Postgres or a Kafka queue whenever there's a change to the bucket, and if file get in place, read or deleted, and you want to throw them to a Kafka queue so something does something about it, you can do that, right? So we support a variety of endpoints for that. You can also configure other things such as replication. So if you want to set replication, let's say to a different cloud provider, right? Let's say all your data on premise, you want to have another data center or another region where you want to replicate the video that we were originally planning to build, or the backups or anything else. You can set the replications rules from here, right? Just tell us what's the URL and the credentials that you'll be using for that replication. Tell us whether you want it asynchronous or synchronous. Asynchronous, as soon as the file gets placed, we'll start replicating it. And the nice thing about asynchronous is that you can actually throttle the bandwidth. But the synchronous replication, that means that as soon as the file gets placed, whenever you get the 200 status reply, that means that the file was already replicated to both locations that you have set up. So, and as Ur mentioned, you can do this on the whole bucket or down to per file, right? I can say only files that are under this folder or have these certain tags are the ones that I want replicated. I can control lifecycle. This is part of the hybrid cloud strategy, right? The lifecycle management rules is where I say, well, I want the data to be either deleted or transitioned to a different location after a certain amount of time. And this is the configurations that you can do. We support multiple targets that are either S3 compatible or any other blob storage, such as Google Cloud or Azure. And you can be like, okay, I want the data on this specific bucket. Let's say I have a bucket here that tiers data to Google Cloud, right? I have a rule that says after 1 day, any file that I put into this bucket, I want it transition to Google Cloud. And then I want to take my mind off of it, right? So I just know that MinIO will actually do this automatically for me. I don't have to be monitoring or anything, right? And then lastly, other things you can configure is, of course, you can audit which policies access this bucket, which users end up with access to this bucket. You can see the access rules if you want to make part of this bucket public as well. That's it. So everything, I could keep going and show you, features that are supported by the MinIO server, but you get the gist of it, right? The idea of this console server is about self-service. Same thing I show you with the operator, self-service, right? So if you have some smaller part of your IT organization that's going to be taking over object storage management, you can just give them operator, right? And they don't even have to write YAMLs. They can, right? So something I didn't show you, but from this, you can actually also access the YAML. Whenever you create these tenants, we actually generate a CRD that comes with the operator and includes all the information. So you could even take this as the templates for your own automated deployments if you want. So that's the whole idea. So with this, I hope I've walked you through the basics of our operator, coming down from the orchestration. You can provision multiple clusters for different business units or customers with different configurations, different capacities. And then you can delegate that management of the object storage itself to the right team, right? That's actually going to be managing that. And then you have a separation of concerns altogether. So my demo is going to reach up to here and hope to get some questions from you guys, Noe. So back to you, Ur. You're on mute, Ur. There we go.
Yes.
It shows you going. There we go.
Thanks, Daniel. So in summary, what we want to say is MinIO and OpenShift is the cornerstones and the main building blocks for any modern multi-cloud architecture in today's world. The expertise that we have in S3 compatible storage and object storage made it an easier integration work for us to go in and seamlessly integrate into every public cloud. And the fact that you can use MinIO with on-prem technologies as well as edge deployments made it easier for us to be present in across all of these environments and be the abstraction for persistent storage. So that's the key message that we wanted to get across. And Daniel expressed that in a very simply going through it. He took his time to show you every single detail and every single technical integration we have done. But once you get a understanding of what you need, you can do this, as Daniel also said, in 30 seconds and 45 seconds by clicking through that and deploy a MinIO cluster in any of these environments very fast. And the other point that I want to make is MinIO runs on OpenShift and any other Kubernetes environment, and that's quite powerful because you can take MinIO and a standard persistent storage interface to your applications anywhere you're running, multi-cloud, edge, and not only that, you're bringing in all of the full stack enterprise stack that we built over the years for an object storage with high performance, resiliency, the replication we talked about, tiering we talked about, and huge scale that we provide because of our nature, because of our background in high performance work and code that we have written early on. So all of that put together, MinIO is the popular choice in today's modern architectures, whether it's for data lake use cases, people moving from Hadoop to a different data lake and using an object storage-based data lake, data warehouse, or people trying to do analytics using AI and ML technologies, or people who has been to public clouds for a storage perspective, but because of egress and ingress charges and other aspects, they really want to bring their data back, and they're building a net new infrastructure, a modern net new infrastructure using MinIO. That's all we wanted to cover in today's webinar, but we have probably about 10, 12 more minutes, and we'll open it up for questions and answer any questions you have during the Q&A.
Yeah, why don't I just give, as an industry analyst, I'm talking to IT leadership teams and DevOps teams every day. And one of the biggest problems, everyone gets multi-cloud and makes a lot of sense from a resiliency standpoint and a cost standpoint, but it's really complicated. AWS is architected in a different way than Microsoft. And so you're going to hire, teams for your Azure instance, teams for your GCP instance, AWS. It's expensive, it's complicated. So I think you guys are really part of this puzzle of simplifying, OpenShift, and then MinIO is part of this sort of one of the keys to the puzzle of making OpenShift or making multi-cloud affordable.
Yeah.
And then a question for you guys, resiliency is a hot topic right now. We all heard about the AWS outage, but the reality is every cloud provider goes down. So how do you guys help clients with creating resilient applications?
So that's a great point, Dan. And we talked about the resiliency from the aspect of replication. We have shown MinIO has the capability to do active-active. And during the demo and in one of the slides, I also mentioned that MinIO replication supports active-active, active-passive, synchronous, and asynchronous. The key here is if the application is very sensitive and from a failover and a disaster recovery perspective, it can easily use a active-active scenario. And regardless of where they're running, they can be running one leg on AWS and another leg on OpenShift on-prem, and they will have active-active replication going across those two clusters of MinIO. And the replication will just point to the other site when there's an AWS outage, and the on-prem workloads will be just running against the MinIO. The data will be there. And the most important parts of the resiliency when there's an outage is access to data, and they will be able to get to their data no problem. And there are other ways of handling this as well, but the simplest example would be one leg in Multicloud running MinIO and another leg on OpenShift on-prem, and they'll be able to get to their data and fail over immediately.
Great. Why don't we've got a couple questions, and if you've got questions, feel free to enter them into the Q&A. So why don't I read them, and Daniel or you guys can address them. So the first one is, we're currently running workloads on AWS, so we can use S3. Can I use MinIO on OpenShift in my data center to replace S3? Would I be able to run some workloads against S3 and some against MinIO?
Yeah, absolutely. MinIO from day one is designed to be a drop-in replacement for the S3 stack APIs, as well as the S3 service offering in AWS. So we are fully compatible for the API calls that any application written against Amazon S3 will be making against the MinIO endpoint. So you can simply replace S3 and put MinIO, and your application will not see any difference. And that's kind of our motto since the beginning. We always wanted to try for making a seamless API compatibility from an application perspective when they become on-prem or they go to any other place like Edge. We will make sure that they're running against us the same way they used to run against AWS S3. So yes and yes.
Great. I think Daniel in the demo sort of touched on some of those items as well. So here's another question. It's a great question for you guys. So someone's interested in MinIO. So so the question is, I want to test MinIO before buying it. Is the free open source download full featured? How is it different from the paid version? Will I have to migrate my data when I upgrade versions?
Yeah, absolutely. So MinIO is an open source company. We have true beliefs in open source, and the way we handle the feature set is we don't do any gating or any restriction from the open source product that we have. We have AGPL licensing on our open source software. So what happens is there's no software difference between the product from the open source community that you will be using and the product you will be using for enterprise use case. The difference is for the paid version, you are buying commercial license matched together from a subnet support portal perspective. We have a different understanding of support. We have direct engineering access and support, level 4 only and directly. So when you're paying for MinIO subscription, you're getting the commercial license that relieves you from all of the copyleft restrictions and AGPL, and you're getting the subnet access, which is kind of a Zendesk/Slack type of a environment that we built on our own, which is quite popular and very impressive to many of our customers because they get 24/7 direct access to engineering with that support and subnet portal. And the paid version or the paid engagement, commercial engagement with MinIO through subscription is that. We don't gate any features, and people can download the software, put it on their laptop, start playing with it, learn about it, integrate into their application. When they go into production, then they come to us from a commercial aspect and commercial engagement.
So here's another question. We've got a global audience on this webinar, which is great. So Kenneth is from Africa, from Kenya, and he's part of a small company and wondering if he can become a member of that of the user group.
Yeah, absolutely. Our community is open to anybody. You can go to our website and sign up for our Slack channel and become part of our community, become a part of our Slack channel there. And there are thousands of users of MinIO. They are talking about their deployments from hobbies to enterprise users. Everybody is there talking about where they deployed MinIO, what kind of integration they've done. So sign up for our Slack channel and go to our GitHub page. There are a tremendous amount of, apart from our website, there are a tremendous amount of information there.
Yeah, on GitHub, you can even collaborate on our source code.
Exactly.
So we've got 5 minutes left. Why don't we end? It doesn't look like there's any more questions. So why don't we end each of us giving a quick thought? And mine is, MinIO is one of the pieces of this multi-cloud world, and it's actually solving real pain points. It's not technology for technology's sake, but it's also making it easy. And it's just multi-cloud is so difficult that anything to sort of abstract the complexities. I mean, that's why RedHat OpenShift is so popular. Sort of people are standardizing with OpenShift, and that's why MinIO has a huge user base. Of course, the speeds and feeds are important as well. So, Or, do you want to give your sort of wrap-up thoughts?
Yeah, my one sentence or two is 20 years ago, hypervisors took physical servers, abstracted them, made life so much easier for applications using the hypervisor technologies. MinIO is the equivalent of that in a multi-cloud environment for persistent storage. MinIO abstracts the complexity, makes it a single interface through S3 APIs for application, and makes life simpler from that perspective. So we are the new generation of abstraction for persistent storage.
Daniel, you want to give your sort of final thoughts?
Yes, keeping things simple and consistent. I mean, you'll be surprised how far you can get with just taking a very basic concept and doing it everywhere. And the fact that you can run, the same storage everywhere will make your deployments and your life way easier, right? Now you don't have to deal with the peculiarities of access control or SLAs from different providers. Kubernetes really unlock you to do the same thing everywhere, right? Now you can take it a step further, and you don't even have to pay for object storage, right? It's very interesting. You can even run your own object storage inside Amazon for cheaper than S3, right? So using MinIO. So you can actually do such things. And, it's not like we're asking you to pull a lot of levers and stuff. You saw how easy it was to actually provision it with the defaults. And then as you go by and you get used to it, you want to bring additional capabilities, encryption, terminating TLS, etc. You can actually do that. So that's the main takeaway.
Perfect. And then I know Cody's going to wrap up, but just, or if you want to tell people where they can go to try out MinIO.
Yeah, simply go to min.io, our website. There's a download section, and you can go and download any binary that you are interested in deploying, and just simply download it and start running the commands. It's straightforward. You just run MinIO server and the mount point or the local directory, and your server would be starting right away for a simple test, and if you want to integrate into your application. So min.io is our website. Just go there and download the software and give it a try.
Great. Cody?
Thank you, Dan. So I'd like to thank Ur, Daniel, and Dan for taking the time to put together this presentation, putting together the materials and the live demo, because we know the live demos always do way more than just moving slides and words. So I really appreciate all the work that went into this presentation, guys. A quick reminder, today's session was recorded. you'll receive access to the on-demand shortly after the webinar concludes. And you can also find the webinar living on the DevOps website. You just visit devops.com/webinars and look in the on-demand section. Real quick, our 4 Amazon gift card winners are Pierluigi R, Anatoly G, Jim X, and Mike J. Congratulations, and you should receive that gift card in your inbox. If you don't receive an email, keep an eye on your spam folder. So I'd like to thank Ur, Daniel, and Dan for being with us today. I would like to thank RedHat Marketplace and MinIO for sponsoring today's webinar. And my final thanks goes to you, our audience, for being here with us today for the entirety of our program. This is Cody J. Brown signing off. Have a great day, and please fill out our post-webinar survey.